Simran and Tamana from year 10, and Michael Mutugi from year 11. So our project today will be looking at common terms that you've definitely heard of, and we're looking at food testing. And under food testing, we're looking at foods like starch. We're looking at food starch and proteins. We definitely know what starch is. Every one of us has definitely consumed it in a part of their lives. Starch is like, you guys, I know all of you know bread. Bread is starch, potato is also starch, and the energy giving food. And the digestion of starch usually starts in the mouth. The other thing we're going to be testing on food is proteins. And proteins is a food that is usually digested in the stomach. And most, what it does to your body, it builds your muscles. So most bodybuilders, that's what they actually take. They take proteins so that they can build their muscles. They're bodybuilding foods. And I'm going to hand it over to the rest so that we can demonstrate the experiment of starch in food and protein in food.
The apparatus used is test tube, milk, a pipette, and the reagents are sodium hydroxide and copper sulfate. So first we'll put milk inside the test tube. Milk is a source of proteins.
Zoom.
So now we'll put equal amount of sodium hydroxide. Now we'll mix it.
when you come, you'll have to sanitize. You'll have to pass by Mr. Cleopas so that you can sanitize and sanitize the mic. So, Rwenzori is next.
My name is Kipesh. I'm from Rwenzori House.
My name is Vaishni. I'm from year 9. I'm from Rwenzori House.
Here we are presenting the human exchange of gas. Gas exchange. You can see we have drawn the chart. Here, left branches, external, intercostal muscles, ribs, muscula of the diaphragm, parts of the diaphragm, limbs of the, you can see heart, membranes, and now we'll explain the system of breathing in and breathing out of gas.
Breathing in is also called inhaling. The diaphragm muscle contracts, pulling the diaphragm into a flattened shape. The external intercostal muscle contracts while the internal costal muscles relax, pushing the ribs upwards and outwards. The volume of the thorax increases and the pressure decreases compared to the pressure of air outside. Air is then enters the lungs from outside. Then we have breathing out. Breathing out is also known as exhaling. The diaphragm muscles relax and the diaphragm goes to its normal dome shape. The external intercostal muscles relax while the internal intercostal muscles contract, pulling the ribs downwards and inwards. The volume of the thorax decreases, the pressure increases, slightly above the atmosphere pressure. Then the air moves out of the lungs. Then I have differences between inhaled air and exhaled air. Exhaled air is warmer than inhaled air. Exhaled air, the second one is exhaled air is more moist than inhaled air. The third one is exhaled air has more oxygen than inhaled air. The fourth one, exhaled air has more carbon dioxide than inhaled air. Thank you.
Now, the audience, when we breathe in, what happened to the diaphragm? Anyone want to answer the question? Yes?
It flattens.
Yes.
It does.
When we breathe out,
It takes a.
thank you.
You can be.
It's my team. Why are you sitting in Because we are in Kenya.
To the audience and to the judges, good afternoon. My name is Zahra Jabin from year 9. Good. To the judges and to the audience, good afternoon. My name is Zahra Jabin from year 9. And
I'm Zuhura from year 11.
I'm Takwim from year 10.
and what we would like to present today will be on the food test for glucose. So we start with glucose. Glucose is reducing sugar. This is because it involves the reducing of the alkaline solution of copper 2 sulfate to copper 1 oxide. And then we move on to the experiment.
Okay, so right now I'm going to take. Glucose in powder form, and then this is a test tube. We're going to put the glucose in the test tube using a spatula. This is a spatula. Okay, as you can see, the glucose is inside the test tube. Next, we are going to add distilled water. As you can see, glucose dissolves faster in water. Now we're going to shake it. Can everyone see? This is water and glucose. Now it is dissolved.
Okay, so after the water and the glucose has dissolved, we're supposed to add the Benedict solution, some several drops of it.
Benedict solution is blue in color.
So you're supposed to add the Benedict solution until the mixture turns the bluish color that it's supposed to be. After that, we had water inside the beaker, like halfway, almost full, filling it up, and then we boiled it. And then we're going to add the test tube that has the solution in it, and then we're going to add it in the beaker. We're going to put it there to boil.
Okay, the thing that I'm using with is called a tongue.
So after adding it inside, we're supposed to wait for it to change the color to see if the reducing sugar is present. If the reducing sugar is high, then the color is supposed to just turn to a yellowish, greenish shade, and it's supposed to go from blue to green to yellow, and eventually to this orangish brick red color.
Are you seeing the change? Yeah, good. If you can't see, you come forward.
Yes, so after boiling it up, it changes the color, which means that the orangish color indicates that there is a high amount of reducing sugar present in it, which proves our experiment positive and it was successful. Thank you. Feel free to ask any question.
Mr. Leonard, please, I want to ask them something. How can we prove that any liquid does not have a reducing sugar? You've already showed us that whatever you have done, it has a reducing sugar. But what else can we do so that we prove that there is no reducing sugar?
So to prove that there is no reducing sugar, you can also just add water, like plain distilled water with the Benedict solution. Then you can heat it up and the color won't change. It will stay the same blue, which will indicate that it won't have the reducing sugar in it. Okay. So now we are doing the experiment to show that there's no reducing sugar. Like, the experiment that shows that there's no reducing this happens.
As you can see, there is no change that is happening here.
So what color does it remain?
It just remains the same color it was when we started the experiment. Clear blue. We are not
And the last group for today is Mount Elgon. No, sorry. It is Elgon. Where is Elgon? Oh, they've shifted. It is Elgon with the last demonstration.
Good afternoon, my honorable teachers and students.
Good afternoon,
So we are here to represent the digestive system. So when you chew food, what happens in your mouth and body? We have come to explain. Okay.
My name is Jasmine Kaur and I'm from Elgon and I'm from E11. So we are here with the digestive system. As you can see, we have the mouth, tongue, trachea, we have the liver, we have the gallbladder, small intestines and appendix. Then this part we have salivary glands, esophagus, stomach, large intestines and anus. So what does the mouth do when the food enters? So when the food enters your mouth, it chews and breaks down the food into smaller molecules, then swallows the food down the esophagus. And then the beginning of digestion tract starts with the mouth, and the food is brought to you. You can smell the aroma of the food and your salivary glands, and the salivary glands are activated. Then we talk about the stomach. We have Gaurav here to talk about the stomach.
Okay, so what happens in your stomach when you eat food? Glands in your stomach lining make stomach acid and enzyme that break down food in your stomach. That's when digestion takes place and you go to the toilet to do. And you go to the toilet to remove that waste. And what happens in the pancreas? Your pancreas makes a digestive juice that has enzymes that breaks down carbohydrates, fats, and protein. That's the pancreas work, okay?
Then next we talk about the small intestines. The small intestines are made up of the duodenum, jejunum, and ileum. This intestine is 22 foot long vascular. So the small intestines are basically that breaks food clean using enzyme, and it's released by the pancreas and the bile from the liver. The duodenum is the first segment of the small intestine. It's largely responsible for the continuous breakdown process. The jejunum and ileum lower in the intestines are mainly responsible for the abdomen of nutrient into the bloodstream. Next we talk about the gallbladder, and Gaurav here is to explain about the gallbladder.
You see, this is the gallbladder, this green thing. This is the gallbladder. So what's its function? Let me tell you. Stores and contracts bile from the liver and releases it into the duodenum in the small intestine to help absorb, digest the fats. The fats like in the chips you eat. Everyone has eaten chips. That fat in the chips is digested by the help of pancreas and the pancreatic juice inside it, okay?
Thank you so much.
When you look at your chart, open that chart. When you look at that chart, you can see there is the mouth. And you have told us that there is digestion which takes place in the mouth. Which type of food is digested in the mouth? Is it starch, is it protein, or is it lipids?
Also means in the mouth it's starch which is digested in the mouth.
Correct.
Which liquid is produced in the liver?